Okay, here's another kind of example problem for some of the ones you're seeing on the Larson worksheet. And this is the integral of the tangent squared dx. And we had some of these when we were doing the antiderivative worksheet. And we don't see the secant squared of x dx in here because that's the derivative of the tangent, so we can't use u to the n du. So we're kind of stuck, except we can use a trig substitution, or a trig identity, I should say, not a substitution. We can use a trig identity. And that's going to be from one of our Pythagorean identities. And I'll write this over here so you can see. Remember this one. We all remember that, I hope. That's our major Pythagorean identity there. Like a squared plus b squared equals c squared. Now, if I want to involve the tangent, the squared, if I divide by the cosine squared of x, because this is the only one I remember. There's two other ones involving the tangent and the secant, and then the cosecant and the cotangent. But I don't ever remember those because they're not as easy to remember as this. So this is what I always have to do. I just write it out to write it. And this is going to be the tangent squared. This is going to be 1, and 1 over the cosine squared is just the secant squared. And we know that secant squared is the antiderivative of the tangent. So that works out really nice. So we won't have to do a U-substitution. We'll just rewrite this. So we rewrite this integral as, instead of writing the tangent squared, I can write, if I subtract 1 from both sides, I guess I should do that over here, so you see. Minus 1. So I'll just rewrite this. Instead of writing the tangent, I'll just write it as the secant squared of x minus 1. And I just take the antiderivative of each term. Because what's the antiderivative of the secant squared? That's just the tangent, so that's just the tangent of x minus, and the antiderivative of 1 is x plus c, and you're done. Well, it's pretty easy.